Now we're ready to learn the many ways that we can query a MongoDB database to get our documents back out. Of course, this isn't going to be much use if we don't have many documents in our database, so we're going to start with that. As you can see, here on the desktop, I have a bookmarks.js file. Let me go ahead and open a terminal, and I'll move to the desktop, and then let's open this bookmarks.js file in Vim. As you can see, we assume that we already know what the DB is, so by the time we load this file, we will have to have chosen the database, and we'll talk about doing that in a second. But you can see that we dropped the users collection and dropped the links collection, and we'll talk more about dropping and deleting in a future video. And then we just go ahead and insert some things. Now I should just mention, remember, if the users collection and links collection don't exist, nothing's going to happen here. MongoDB won't throw an error, it'll just go ahead and fail silently. So then we can go ahead here and we are inserting 3 different users. Notice I've tried to vary the number of things that we have here. We have name here, which is an object with first and last properties. We have their age, email, password, hash, and then we have a list of logins here. And these are the times that they logged in and the length of time that they stayed logged in for. And you can see that I've got 3 different users here. And then here I get references to each one of these users, and we'll be talking more about the find one method in this very screencast. And then down here, I'm just creating a bunch of links in the links collection, and you can see that we have the title, the URL, a comment on that link, some tags, how many times this link has been favorited in our little bookmarks application, and then we have a user ID, so we know which user saved this link. And I've got about 12 different links here. So now, we are ready to go ahead and load this into MongoDB. So I already have the MongoDB server running. So let's go ahead and run Mongo. And I'm going to type 127.0.0.1. And this, of course, just means localhost. And then what I'm going to do is say /bookmarks so that it knows we're talking about the bookmarks database. And then I'm going to go ahead and load the bookmarks.js file. So then this just tells it that using the bookmarks database on this localhost server here, run all of the code that's in the bookmarks.js file. So when I go ahead and hit enter there, you can see we just have that header information put out, and now that file has been run just fine. So now I can go ahead and go Mongo bookmarks to connect to the bookmarks database, and now we have our terminal, and if I just run db.links.find, you can see that we have a whole bunch of stuff put out here. So this is all of the links documents in our links collection. So now that we have all this data in here, we can go ahead and start querying it. So the first way to query our table is to just ask it for all of the records. And we can do that, as you've just seen, by saying db.collection name. In this case, let's do the users collection. And then we can say .find. And when I hit enter here, you can see that this is printed out. Now, unfortunately, the JavaScript console doesn't really give us a very pretty output here. It's just basically a long string of JSON wrapped to the length of my terminal. What we can do to make this a little prettier is say for each after this, and then we can just pass it the print JSON function. And what this will do is give us a prettier version of all of our data. Now we have a lot of data being printed out here because each of our user objects are pretty extensive, but we'll look at some ways of simplifying this as we go along. Now, we can also do this, of course, with the links. If I just say db.links.find, again, we'll just pass it for each.printJSON. And there you can see now we have all 12 of our links here being printed out in the same way. So first way to query our collections, just call the find method on the collection and it will return everything that's in that collection. However, you know as well as I do that often we don't just want to get everything, we want to get specific things. So let's look at how we can narrow down those results. The first thing we can do is pass a object, and this is going to be a query selector object, to the find method. We'll do this on the users collection here, so we can say db.users.find, and what are we going to put inside of this object? Inside this object, we're just going to put a field name and a field value. So in this case, let's do email, and we'll set the email address as johndoe@gmail.com. Now, I think you can guess what this is going to do. This is going to look through the user's collection and find all of the documents that have an email field that is set to johndoe@gmail.com and return those. So if we hit enter here, you can see that we only have one object here, and it is indeed John Doe. Right here, you can see that it has the email of johndoe@gmail.com. Let's do another one. Let's say users.find, and we want to find the one that has a password hash of another password hash. And this time, I will just say for each, we want to go ahead and print JSON. And you can see that this time we get the document that is Jane Wilson's user information. Now in both these cases, our query has only returned one object, but we can have queries that are going to return multiple objects. For example, let's look for all of the objects that have been favorited 100 times. If we run this query, you'll see that we get nothing, and that is because I need to do that on the links collection instead of the users collection. So now you can see here that we have two different objects here, and they both have 100 favorites. One of the neat things about MongoDB is that this syntax also works for things inside of arrays. So as you can see right here, we have tags as one of the properties on all of our links, and they each have an array of tags. However, if I say db.links.find, and I want to go ahead and find where the tags is equal to code, well, none of our documents have tags set to just the string code. However, several of our documents do have a tag inside of that array of tags that is the string code. So if I go ahead and hit enter here, you can see that we do get two different objects returned from this query as well. And right here you can see that code is one of the tags for the NetTuts link, and code is one of the tags for the Code Canyon link. And one thing you do need to remember is that as we go through these next few videos and we talk about different query syntaxes and operators and that kind of thing, I may just be showing it to you on simple fields like comment with a string or a number like favorites or something like that. But remember that a lot of these work with arrays as well. So if you have an array of strings or an array of numbers, any of the operators that work on just plain numbers will work also on an array of numbers. So arrays really are like having one field that has multiple values assigned to it. Now let's talk about what is being returned here. When I call find on a collection, here in the console, it looks like we're just returning an array of objects. And that is true in some sense on the JavaScript console here, but we're actually returning a cursor object. And this will be more apparent when we're actually using a database driver, how we're not just returned a raw array of values, we returned an object that we can basically interact with. And the reason I bring this up now is because there's another method that's called find1. And this method, instead of returning a cursor, is going to return our single document. So when I say find1, and let's say, for example, we want to find something where the email address is johndoe@gmail.com. This is actually returning our John Doe object right here. Now, if I change this from find1 to just find, besides the output being different, it doesn't look like we're actually getting anything different back. Yes, find1 seems to do the pretty printing for us, but why the difference between find and find1? Well, this is apparent if I go ahead and append a method to the end of this find1 query. Let's, at the end of this, just say name. And if I do that, you can see that we have that sub-document or sub-object inside of our John Doe document. And that's returned just like that. And that's kind of what you would expect. If find1 returns the document, we can just use normal JavaScript to query inside of that document. However, when I do find.name, let's see what we have. Nothing at all is returned. Now we don't get an error, but we don't get anything useful either. And this might throw you for a loop because you're thinking, well, I know that this query will only return a single item from our database. Yes, but the method itself doesn't know that, and we're using a method that returns a cursor object, not a single document. So keep that in mind when you're querying your database. So up until now, all of the queries would have the SQL equivalent of something like select star from users table where whatever, right? And the select star part is the part I'm trying to emphasize here. We're getting all of the fields out of each of our documents. However, often you're not going to want to get every single field, and so a proper use of resources would say we want to limit this to just the number of fields that are going to be relevant at the time. So this is actually not very hard to do in MongoDB. We can do this by passing a second object parameter to the find method. So let's go ahead and say db.links.find, and we want to find all of the objects that have 100 favorites on them. And we have two different objects here. One is NetTuts and one is Audible. But when they're printed like this, it's kind of hard to see which ones they are. So we can go ahead and pass a second object here, and this will just have a list of the fields that we want to be included in the document. Now, it's not just an array of field names. Look at how this works. I'm going to say title equals 1, and I'm going to go ahead and say URL equals 1 as well. Now, I could use the value true here instead of 1. In fact, let me use it for the second one here. But most of the documentation you'll see will use the number 1 instead of a Boolean value. If I do this, notice that we get significantly less output. Let me widen this up a bit. You can see here that we got an object ID for each one of those documents, and then we only got their title field and their URL field. What we've done here when we say title1, URL1, is we've said these are the only fields that we want to include. Now, the ID field is included by default, but these are the only fields that we want to retrieve from our database along with the default ID. Now we can do the opposite here, and instead of including, we can exclude. So let's say we want to get everything except the tags. I can just set tags to 0, and of course false would work in this case as well. And if I go ahead and do our for each print JSON, just so this is easier to look at, you can see that these two documents have everything except our list of tags. Now, one thing to note, we can't mix including and excluding in the same object here. You either need to choose which ones you want to retrieve or which ones you want to ignore. There's one exception to this, and that is that I can say _ID equals 0, or I can exclude the ID while I'm asking it to include certain other fields. So here I'm saying just the title and URL, and please specifically don't send the ID along with it. You can see that we just have the title and the URL in both cases, and the ID was not retrieved. Now, we talked a little bit about nesting objects in our last video. This is really handy when we want to add a little bit of extra categorization or depth to our documents, but you might think that it makes it more difficult to query these documents. This is actually not the case at all. We can use the dot notation. So let's look at this. We can say db.users.find, and I can say name.first. Remember, name was an object that had a sub-object which had a first field inside of it. So I could say name.first equals John. And if I change this to find1, you can see here that we do get the right object here. And so we've just done name.first. So it's just like the JavaScript syntax, and we can use that to query inside of sub-objects. And the neat thing about this is that it works in our selection object as well. So here I can say name.last equals 1, and now all we're going to get back is the ID and the name with the sub-object, and it only has the one field last inside of it. So we've only selected one field here from our object. So this dot notation is really handy if you have a lot of nested documents. So before we wrap up this video, let's do one more example that's a little bit more complex, and we'll use some of the different tools that we've learned in this video. Let's create a variable John, and this is going to be db.users.find1, and we're going to go ahead and find where name.first is equal to John. In this case, we know that there's only going to be a single document that has the name of John. I should point out here that if when we use the find1 method, our selector here matches more than one document, it will return the first one that it finds. And of course, since they are stored by default in natural order, which is the order they were inserted, the first one will be the oldest document in our collection to match this query. However, in this case, we know that there's only one document with the name John. As you can see, there it is right there. And so now let's go ahead and get all of the links that John has created. So I can say db.links.find, and we want to find where the user ID equals John._ID. And let's limit this by only returning the title for the link, and we'll tell it that we do not want to include the ID. So now, if I go ahead and enter here, you can see that we have 4 different links that John has made: NetTuts, Tuts Plus Premium, Amazon, and Theme Forest. So this little example we've done here uses pretty much everything that we've talked about in this video. We've looked at our query parameters here, we've looked at the dot notation, we've looked at find and find1, and then we've also looked at limiting the fields via the selector object here. So this shows you how all of these little things can add up to make a pretty powerful query language. And I think one of the beautiful things about it is it's completely written in JavaScript. We don't need to learn a second language like SQL to work with our database. We can use something we all are already familiar with, and it makes querying our databases so much easier.